Hi to all. Today I am going to explain the topic critical angle. What is critical angle and at what situation we will define this critical angle? What is its relation with the refractive index that I am going to explain. First of all, to explain the critical angle definition, I have to explain one thing that when the light ray is trying to move from denser medium to rarer medium, if the light ray tries to move from denser medium to rarer medium, then it will bend away from the normal that we know already. For example, this is the boundary which separates the two mediums, and below this denser medium is there, above this rarer medium is there. For example, this is the source of the light, then the light starts from the source in the straight and it is incidenting it here. In this case, what is the angle of incidence? What is the angle of incidence? The angle of incidence is the angle between the incident light ray and normal drawn. Look at here, this is the normal drawn and this is only incident light ray, and that's why here angle of incidence becomes 0. And then when angle of incidence is 0, according to laws of refraction, angle of refraction also 0. That means that light will go in straight without any bending. It will go in straight. And for example, we will take another light ray. It will goes like this, and it will incident on the surface separating the two mediums. And now here, what is the angle of incidence? To know the angle of incidence, we have to draw the normal. And for example, I want to draw the normal at this point, normal to the surface, and this is the normal drawn to the surface. Here the angle of incidence is considered as some I, and here the light ray will be refracts and it will bend away from the normal. That means it will not go in straight like this. Okay, it will not go in straight like this because of change in medium. It will bend away from the normal. Okay, what is this? This is the normal drawn, and it will bend away from the normal, means like it cannot go like this. It will bend away from the normal, this side it will bend, and then it will go like this, right? And here angle of refraction is the greater than angle of incidence. Okay, here in this case we write here r is greater than I. For example, we are taking the another light ray that is emitting from the source, and it is allowed to incident at this point. And here I want to know the angle of incidence. For that I have to draw again normal, right? And then for the purpose we have to draw a straight line that should be perpendicular to the boundary. Boundary is the surface which separating the two. This line is the boundary which separates the two mediums. Below this boundary denser medium is there, above this boundary rarer medium is there. And now how the light will goes, and light, when the angle of incidence is increases at here, when the angle of incidence increases, automatically when you comparing to this, here the angle of incidence is increased. When angle of incidence is increased, angle of refraction also increases when light moves from denser medium to rarer medium. That's why further it will bend away from the normal. Okay, then it will bend like this. It will bend like this. This is the angle of refraction in this case. Okay, and now for example, we are taking the one more light ray from the source, and that is incidenting at this point. Here the angle of incidence is further increased, right? The angle of incidence further increased. I want to know the angle of incidence at here, and this is the angle of incidence. Now in this case, again the further the light ray bends away from the normal, that means it will bend. Here there is no bending, here some bending, here more bending, here again some more it will bend, and finally the light ray will goes along the surface, right? That means now the light ray will go along the surface. It will go like this, right? And now the angle of refraction equal to 90 degree. Angle of refraction equal to 90 degree for certain angle of incidence. For certain angle of incidence, right? In the denser medium, angle of refraction become 90 degree. Light ray grazes the surface. This is to be here. The light after refraction, light ray grazes the surface, means moves along the surface. Right here, angle of refraction is 90 degree. Then certain angle of incidence is called as critical angle. This angle of incidence is called as critical angle. Right? What is the definition of this critical angle? When light ray is trying to move from denser medium to rarer medium, what happening it here? It will bend away from the normal. If we increase the angle of incidence, for certain angle of incidence, angle of refraction become 90 degree. Corresponding to that 90 degree angle of refraction, angle of incidence is called as critical angle. That means angle of, if angle of refraction is 90 degree, right? If angle of refraction is 90 degree, then corresponding angle of incidence is called as critical angle, right? This will happens when the light ray moves from denser medium to rarer medium, because when light ray moves from denser medium to rarer medium, at that moment only it will bend away from the normal. That is, we can define like this: when the light ray moves from denser medium to rarer medium, okay, denser medium to rarer medium, the angle of incidence in the denser medium at which angle of refraction become 90 degree, that is called as critical angle. Critical angle is the angle of incidence in the denser medium at which angle of refraction become 90 degree. At what angle of incidence angle of refraction become 90 degree, that angle of incidence is called as critical angle. Okay, note carefully. And now I am going to continue. That is, I am going to derive the relation between the critical angle and refractive index. Now the next topic is relation between the critical angle and refractive index. Relation between refractive index and critical angle. Refractive index and critical angle. Then what is the relation between them? Relation between the refractive index and critical angle. Then I am going to derive the relation between the refractive index and critical angle. For the purpose how we can derive the relation, then for that purpose I will draw once again the diagram, and that is, we know that this is considered as the boundary which separates the two mediums. For example, this is the boundary which separates the two mediums, and below this we have the uh, denser medium, and above this we have the rarer medium. And the rarer medium, denser medium absolute refractive index we can consider as nu d, and rarer medium absolute refractive index is nu suffix r. And now, for example, we want to draw normal at here. The normal means it is a line which is perpendicular to the surface. For example, this is the normal drawn at here. This is the normal drawn, and here we are making one light ray to incident on the surface. Okay, this is the angle of incidence, and here the angle of incidence we can consider as equal to critical angle. That means in this case the light ray grazes the surface, and in this case the angle of refraction is equal to 90 degree. Okay, right. Now I am going to derive the relation between the refractive index of denser medium and critical angle. For that we know according to Snell's law, right? According to Snell's law, what we know? According to Snell's law, we know that refractive index of second medium with respect to first medium, right? Refractive index of second medium with respect to first medium. Refractive index of second medium with respect to first medium, right? Refractive index of second medium with respect to first medium, we know the formula, that is refractive index of second medium with respect to first medium is denoted with 1 u2. That 1 u2 formula we have sine I by sine r. But one thing we know, that some conditions we know, that in the diagram from figure, but from figure we write something. What we write from figure, that is from figure we write angle of refraction as 90 degree, and angle of incidence as critical angle, that is the C is the critical angle. And then what about the 1u2? 1u2 is the refractive index of second medium. Here second medium means with respect to first medium. First medium means where the light ray starts, that is the first medium. Where the light ray moves, enters, in which medium the light ray enters, that is called the second medium. And now 1u2 we write as refractive index of denser medium. First medium is the denser medium. Okay, this is the medium 1, this is the medium 1, and this is the medium 2, right? Medium 2 is the rarer medium. Then we write here 1 nu 2 as r nu d, sorry, d nu r we write, because first medium is the denser medium where the light ray starts, right? And in which medium the light ray is enters after the refraction, that is the second medium, right? The second medium is the denser to rarer it is going, first to second it will goes. Then we write here d nu r we write. We know d nu r formula, right? If you want we can write nu r by nu d. It is not required. And this we substitute in above equation all conditions, right? And this is equation 1, and from equation 1 we write something, that is from equation 1 what we write. From equation 1 we write, that is d nu r is equal to 1 nu 2 is d nu r, it is equal to sine I is the C by sine r is the 90 degree. Okay, but the this we write as d nu r is equal to sine C we write. But this d nu r, this is the relation between the refractive index and critical angle. Now let us see here. This is the relation between the refractive index and critical angle. But one more formula we know, that this we can consider as equation 2. That is the d nu r in terms of r nu d. If you want to write d nu r means what? D nu r means what? D nu r means refractive index of rarer medium. Refractive index nu r means refractive index of rarer medium with respect to the medium, with respect to rarer medium, with respect to denser medium, it is with respect to denser medium. But we know one thing, that is d nu r we can write as d nu r we write as 1 by r nu d we write. 1 by r nu d we write. This is equation 3 we can write. Now what we have to do, equation 3 substituted in 2. Okay, we write equation 3 in 2. When you write the equation 3 in equation 2, in place of d nu r we write r nu d. 1 by r nu d we write, that is 1 by r nu d. 1 by r nu d is equal to we write as sine C. It's a reciprocal equation we write, right? Then when you will write the r nu d formula from here, if you write r nu d, then we will get as 1 by sine C. This is the final formula that we are getting it here, that is the dr nu d is equal to 1 by sine C, and this is equation 4. Okay, this is the relation between the refractive index and critical angle. What you got the final formula? The final formula we got is, okay, if you want we can write here, that is u got is d nu r is equal to, we got is 1 by sin c. D nu r is equal to 1 by sin c. What is d nu r in this? D nu r is the, sorry, this is not d nu r. What is that? From equation 4, it is r nu d, right? It is the r nu d. What is r nu d? D nu r we got sin c, but r nu d we got is 1 by sin c. R nu d means it is the refractive index of denser medium with respect to rarer medium. Okay, from equation 4, r nu d is equal to 1 by sin c. And then let us see here, what is r nu d? I will write it here. What is r nu d? Right? What is r nu d? Refractive index of denser medium, denser medium with respect to, with respect to rarer medium, rarer medium. Okay, this is r nu d, refractive index of nu d, refractive index of denser medium. Backside we are writing r, that means refractive index of denser medium with respect to rarer medium. This is the relation between the refractive index and critical angle. Okay, and note it. And now I am going to continue after the rubbing. Now note, I am going to give one point in the note, right? You note it. That is, what is the relation between the refractive index and critical angle? Relation between refractive index and critical angle we got. Relation between refractive index and critical angle. What you got? Yes, we got is like this. That is r nu d. R nu d is equal to 1 by sin c. This is the formula. If you want critical angle from this, okay, what is r nu d at here? R nu d is the refractive index of denser medium with respect to rarer medium. Look at here, r nu d we want to write. It is the refractive index of denser medium with respect to rarer medium. This we write as nu d by nu r we write. Nu d by nu r we write. Now let us consider, we will take some pair of mediums, and for that we can find out the critical angle. If you want write in this, we write nu d by nu r is equal to, we write as 1 by sin c. Okay, from this if you want the critical angle, we can find out critical angle also. Let us take some examples. I will give some values of the critical angles for the pair of mediums. C depends upon, C depends upon critical angle of denser medium and rarer medium. C depends upon pair of mediums. Pair of mediums. Let us see here. I will take some examples it here. Okay, I will take some examples. First, let us take the glass and air. Glass and air. For that, the critical angle is what? For the glass and air combination, you will get the critical angle as, oh, we know for in case of glass air combination, what is the refractive index of glass? Glass means glass is the denser medium, right? It is the 1.5, and air is the rarer medium. Its value is 1. When you take the glass and air, glass is the denser medium, air is the rarer medium. Okay, then these values you substitute in this nu d value, nu r value, then you will get the c value. That is, c value we will get it here as 42 degree. 42 degree. Okay, the critical angle for the glass air is 42 degree. And let us take the another combination, that is the glass and water we will take. For the glass and water, what is the critical angle value? In this, glass refractive index is 1.5, water refractive index is 4 by 3, it is 1.33 something, it will be there. Glass has more refractive index, it is the denser medium, that is the denser medium refractive index is 1.5, and the rarer medium is the water refractive index is 4 by 3. And if we substitute these values in this formula, and if you will find out the critical angle, we will get it as the 49 degree, right? At 45 9 degree, if the light ray incidence, then it will raises, right? It will angle of refraction will become 90 degree. If you take the diamond and air combination, right? If you take the diamond and air, the diamond has refractive index 2.4, right? The diamond has the refractive index 2.4, it is the denser medium, and air has the refractive index 1, that means it will act as a rarer medium. And for this combination, if you will find out the critical angle, just you will get the 24 degree. That means the critical angle of the combination of diamond and air is very less. Okay, thank you.